Our next lesson is about compound and continuous interest. So this also involves exponential functions. We have a special formula that we use. So in this formula, the a value is going to represent our final amount. The p value represents the principal or the initial amount. So in banking questions, that's going to be how much I deposited. Again, R is going to be my rate, but as a decimal. So be careful to move your decimal over twice because percents are out of 100. So we move our decimal twice. N is going to be the number of compounding periods. And we'll explain more about that. And T is going to represent the number of years. Let me add to that, number of compounding periods per year is what N stands for. So N is going to change based on our questions. If N equals 1, it compounds one time a year, that's annually. If N equals 2, semi-annual is going to compound twice per year. Quarterly is going to compound 4 times. Monthly is 12 times. Weekly, there are 52 weeks in a year, and sometimes it compounds daily, which we're going to use 365. So that N value could change in each question depending on how often it compounds. So let's see how this works. Your uncle gives you $5,000 for your 16th birthday. Nice uncle. You invested into a bank that pays this much interest, compounded quarterly. Find your balance after 3 years. So what is my initial amount that I plugged in? $5,000. The 1 is just always there. So our rate is 2.92%. When we change this to a decimal, we move our decimal back 2 spaces. So that's 0.0292 over. N represented the number of compounding periods per year. It was compounded quarterly, so that's a 4. And my power is N times T. So N was 4, and my T is the 3 years. So what this is saying is it's compounding this much, but it's going to do it 12 times because it's 4 times a year times 3 years. And now I just carefully plug this into my calculator. So here goes. 5,000 parentheses 1 plus 0.0292 divided by 4. And you could use the fraction button if you want to, if you like the way that looks, to the power of 4 times 3. Or you could just multiply that and put 12. And we are going to find out that we'll have $5,456 and 2 cents. So this was my R that I made into a decimal. This was my T for how many years, and that was my N for how often, how many times per year it got compounded. All right, let's see what happens on the next one. You win $1 million in the lottery. Isn't that nice? You put that money into an account for 10 years. There's my T value. This is my initial value. At an interest rate of 4.9%. So remember, rate as a decimal, 0.049. You move your decimal back 2 places. All right, compounded annually, that means T is 1. So let's plug this in. $1 million, that's 6 zeros, times 1 plus my rate, 0.049, over 1 to the power of 10 times 1. I need to change that to an N. And I'll just put this in my calculator. 1, 2, 3, 4, 5, 6. 1 plus 0.049 to the power of 10. So if I do that for 10 years, I'm going to have $1,613,447.66. So when you hear people talk about living off of the interest, that $1 million is now $1.6 million. So we've earned some money there. Quarterly, I'm going to be compounding 4 times a year. So I'm going to take the same equation, 1, 2, 3, 4, 5, 6. But this time it's 0.049 divided by 4 to the power of 4 times 10. So this is your n, and that's also your n from your formula. So I'm just going to, I'll type it all over again. 1, 2, 3, 4, 5, 6. 1 plus, now for those of you who want to see it in a fraction, 0.049 over 4. So you could do that to the power of 4 times 10. Here goes. Well, now I have $1,627,000. So I've got just a little bit more money if it's compounded quarterly. Now we're going to compound it monthly. Monthly is 12 times a year. So we take our $1 million, 1 plus 0.049 over 12, and then it's 12 times 10. Because remember that exponent said n times t. 10 years, 12 times a year. So now I think I'm just going to grab that previous question and we'll just edit some numbers. We're going to make that a 12, and then we'll come up here and make that a 12. So divided by 12, and then my exponent was 12 times 10. Now I've got $1,630,000, 688.47. So it should hopefully make sense that as we compound it more frequently, we're going to have a little bit more money. All right, next up, Tom and Jerry. They're buddies for this problem they are. They each have $250. Tom puts his money in an account with 3% annual percentage rate. That's what APR stands for, compounded weekly. Jerry puts his money into a 2.5% account, compounded daily. Who has more money in 7 years? So this is the way we tricked you to doing 2 separate problems. I'm going to do one problem for what Tom did, and then I'm going to do the same problem with the numbers for Jerry. So Tom started with $250. And he earns 3% interest. So that's going to be 0.03. And his is compounded weekly. So n is 52. And we're going to do that for 7 years. 52 times a year for 7 years. So you literally plug your numbers into the formulas. So let's calculate what happens to Tom. Well, that just makes it clear. So Tom's got 250. 1 plus 0.03 divided by 52 to the power of 52 times 7. So Tom's going to have $308. $308.40 at the end of those 7 years. Let's see what happens to Jerry. Jerry takes his $250. His interest rate is 2.5. So I'm going to write that as 0.025. And his compounds daily, which is 365 times a year, times 7 years. Well, Jerry has a lower interest rate, but his is compounded more frequently. So let's see who ends up with more money. 250 1 plus 0.025 divided by 365 to the power of 365 times 7. Well, Jerry's got $297.81. So what was the question that they asked us? Who has more money in 7 years? Well, I think Tom wins. He's got more money than Jerry. And our last piece for today is a formula called continuous interest. So this one, I call it the PERT formula because it's A equals P times E to the RT. So E is kind of like pi. It's a number in your calculator, and it's the same number every time. So there's 2 ways to get to this E button. If you go over here on the left side, there's an ln. Right above it, it says e to the x. So if you want to do your e value, you do second ln, and that gives you e to whatever power. If you just wanted to look at the e all by itself, that's right above the division sign. So if I go second divide, that's just plain old e without a power. And this is what it's kind of like pi. Pi is 3.14159 every time. Well, this is 2.718 every time. So that's the E value. So again, A stands for the final amount. P stands for the initial amount. R is your rate as a decimal. And T represents the amount of time, usually in years. And this E is found by going to second and then the button that says LN. That's going to get you to your E. So here we go. They're going to tell us it's compounded continuously. And so we know to go to this formula. You deposit $2,000 into an account that pays 8% compounded continuously. So A equals P E to the RT. P is my initial amount, my 2,000. E to the power of 8% as a decimal for 3 years. So there's my rate, there's my time. And I just plug this into my calculator. So 200, and I'm going to go second ln e to the 0.08 times 3. And I have $254.25. So compounded continuously is even more than compounded daily. Compounds it a little bit faster. Number 5, you deposit $500 into an account that pays 4.5% annual interest compounded continuously. How much will be in your account after 5 years? Here we go. There's my P. E to the rate, remember, move it back twice, 0.045 times 5 years. Let's see how much money we'll have left. 500, second ln, e to the 0.045 times 5. And we're going to have $626.16. All right, we got a ways to go before that's going to double. So I know it's more than 5 years. So we're going to do the same thing we did on the previous questions. We're going to plug this into y equals, and I'm going to type in 500 e to the 0.05x, and then I'm going to check my table to look for y equals, they wanted to double, so 1,000. I'm going to look at my table for y equals 1,000. So here goes. 500 e to the 0.045 times x. Now go to the table. We already said I know it's more than 5 years, So let's scroll down till we see 1,000. We're getting close. Oh, there it was. Somewhere between 15 and 16, I crossed 1,000. So how long will it take it to double in value? 15 to 16 years. And there we go. All right, and I believe what's up next is some practice on that.